Okay, Wildcats, today we're looking at Thursday, February 28th, Graphing Rational Functions, Part 1 on page 49. Okay, now you'll notice that we have two page 49s because attributes and graphing go together. Okay, and in fact, we're going to use the same notes from attributes for graphing. Also notice that we have a Part 2, Part 3, Part 4, and Part 5 of graphing rational functions. It's because this is a very difficult concept. So today we're just going to do the examples. Friday we're going to do an assignment. Monday, Tuesday, and Wednesday we'll do assignments. So that way we have lots of practice on this. So hopefully after Wednesday, March 6th, we'll have a good idea of how to graph rational functions, okay? If you would, update your table of contents. All right, now your table of contents are up there. Let's take a look at the notes. Now, there's not new notes, okay? No new notes. Okay, we're going to use these. I'm pulling this page out so we can use it for today, okay? So graphing rational functions with attributes of rational functions. We already done this. Okay, graph rational function steps. Step 1, factor the expression. Step 2, identify the holes. Step 3, find the vertical asymptote or asymptotes by setting the denominator equal to 0 and solve for x. Step 4, find the horizontal asymptote or asymptotes or the slant asymptote by using long division. Step 5, find the X-Intercepts or the zeros by setting the numerator equals 0, solving for x. Now, here's what we didn't do in the previous lesson. We didn't do step 6, graph the above information, and step 7, graph the critical points. And that's what we're going to do today's lesson. So if you would, we have your notes. Let's put it off to the side, and let's go through our examples. All right. Find the zeros, vertical asymptote, horizontal asymptote, and holes, then graph the rational function. Almost forgot that's on page 49. All right, so the first thing we're going to do is factor. Okay. Now we know since it's x squared is 2 parentheses, and there's nothing we can do with it divided by x. Now x and x make x squared. Okay. Now we need to find the combination that makes -6 and combines to be 1. So we know that -1 times 6 is -6. And -1 plus 6 is 5. That doesn't work. All right, now let's try -2 times 3 is -6. -2 plus 3 equals 1. So they multiply to be -6, combined to be 1. Factors are x minus 2x plus 3. All right, now nothing divides and becomes 1, so there's no holes. Okay. Now our next step, and in my notes we say vertical asymptote. We're going to vertical asymptote by setting the denominator equal to 0. So x equals 0. Well, that means our vertical asymptote is x equals 0. We're going to do that in yellow, and it's also going to be a dashed line at 0. Okay. Now our next step is we're going to find the horizontal asymptote or slant asymptote by dividing. So we have x divided into 1x squared plus 1x minus 6. Now you ask yourself, what do you multiply x by to give you x squared? The answer to that is 1x. Now there's an x, so we know it's a slant asymptote, but the quotient is incomplete, so we need to continue on. So we multiply 1x times x is 1x squared. We subtract, that cancels, we bring down the 1x. Now, what do you multiply 1x by to give you 1x? The answer to that is plus 1. The quotient is done. And in essence of space, I can write it here. Y equals 1x plus 1 is our slant asymptote. Okay. Now, it's important to note that when we say y equals 1x plus 1, well, we need to divide this by 1 because that's our slope, and slope is always a fraction. Okay, so to graph this, we start at 0 positive 1. And then our slope is rise 1, run 1. So we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, so on. And then we can actually go left 1, down 1, left 1, down 1. Okay? Now, the slant asymptote is also a dashed line. Okay? And they get a dashed line, I do every other point. All right. Now, for the critical points, okay, we need to find a point that shows with the curve here and here, and that's where we can use the calculator. Okay, so we're going to graph that. We're going to go to New Document, Add Graph, press Control Divide, x squared plus x minus 6 divided by x. Now I'm going to go to Menu, View, Grid, Line Grid. I apologize, that's my phone. It's probably a telemarketer, so we don't want to answer it. All right. Now it looks like here, that point right there is negative 2, 2. So we can use that point. So we go negative 1, negative 2, positive 2. Okay. And we know from our graph that our curve is right here. Okay. And then it looks like we can use this point negative 2, 0. Or I'm sorry, positive 2, 0. And we know from our graph that our curve is right here. All right. So go ahead and finish up graphing and let's write our critical point. So our critical point was negative 2, positive 2, and negative 2, 0. And that tells us where the curve is. Okay. All right. Now let's take a look at example 2. Okay. So first thing I'm going to do is factor. Okay, now we can divide 2x squared minus 2 divided by 2. Okay, so that becomes 2x squared minus 1. But that's a difference of squares, so that's factored as x minus 1 times x plus 1. Okay, now this is a difference of squares as well, so that's x minus 2, x plus 2. All right, now nothing divides and becomes 1, so that's no holes. Okay, now our next step is to find the vertical asymptote, and that's found by setting the denominator equal to 0. So x minus 2 equal to 0, x plus 2 equal to 0. All right, so here we add 2 to both sides. So x equals 2. And here we subtract 2 from both sides, so x equals negative 2. And I put it in pencil, but we're going to do the vertical asymptotes in yellow. So we have a vertical asymptote at x equals negative 2. And x equals 2. Okay, now to find the horizontal asymptote, we divide, so we have x squared minus 4 divided into 2x squared minus 2. Okay, so the question you ask yourself is, what do you multiply x squared to give you 2x squared? The answer to that is 2. There's no x, so it's a horizontal asymptote at y equals 2. Okay, so that's just a horizontal line at y equals 2. Now, I forgot to find the zeros in example 1. So I'm going to do that example 2, finish example 2, then we'll come back and get the zeros from example 1. Okay? All right. So now we need the critical points. We're going to graph this to find those points. Okay? So we're going to go to on, new document, no, add graph. So we're going to press Control Divide 2x squared minus 2 divided by x squared minus 4. I'm going to go to Menu, View, Grid, Line Grid. So it looks like I have a good critical point at -1, -2, -3, 1, 2, 3. So let me say 1, -1, 2, 3, 1, 2, 3. So -3, 3. Now I'm going to put a dot at the center of the axis so I can see, because I have so many lines. Okay, -1, 2, 3, 1, 2, 3. And we can see from our graph that a curve is right here. So that's one critical point, -3, 3. Now here it looks like we have 2 points that we can use, -1, 0 and 1, 0. And I'm going to erase this point here. And actually, I guess I can put like a little x. So that's where the origin. Now, so that's -1, 0 and 1, 0. That shows us that the curve is here. Again, the reason I have that x is just so I know where the axis is. Okay. All right, and then our next one is +1, 2, 3, +1, 2, 3. So 3, 3. So 1, 2, 3, 1, 2, 3. And our curve is here. Okay. Now, to find the zeros, we set the numerator equal to 0. So we have 2x squared, and I'm going to use space from holes to do that. So 2x squared minus 2 equals 0. So we add 2 to both sides. So you get 2x squared equals 2. We divide both sides by 2. This becomes 1. This becomes 1. And almost ran out of speed. So we have x squared equals 1. Well, we know that -1 squared is 1 and +1 squared is 1. So our zeros are -1, 0 and 1, 0. Okay. All right, now let's go back to here to find the 0. Okay, so we set the numerator equal to 0. So we have x, and again, I'm going to still space here. So x minus 2 equals 0, x plus 3 equals 0. So we add 2 to both sides. So x equals 2. So we have a 0 at 2, 0, which makes sense. It's right there. That's one of our critical points. And here we subtract 3 from both sides. X equals -3. So we have a 0 at -3, 0. And it looks like as we do the curve, we pretty much hit it. So -3, 0. Okay. All right. So you can see that there's a lot in example 1, example 2. So just be careful as you're working, as I myself forgot the zeros here. So just be careful not to forget things. All right, now let's move on to example 3. All right, so here the first step is to factor. There's nothing you can factor. Nothing becomes 1, so there's no holes. Okay, next step is to find a vertical asymptote. So to do that, we set the denominator equal to 0, so that's x squared equal to 0. So we square root both sides. So x equals 0 is our vertical asymptote. Okay, so x equals 0. All right. Now our next step is to find the slant asymptote by dividing. So we have x squared divided by, now this doesn't have x squared, so it needs it. So 0x squared plus 1x minus 1. Again, this is the most difficult step, okay? Now you ask yourself, well, what do you multiply 1x squared to give you 0? The answer to that is 0. There's no x, so it's a horizontal asymptote at y equals 0, which is again a dashed line. Okay, at 0. Now, let me try not to forget the zeros like I did before, and you might need to steal space for that, but you set the numerator to 0, so x minus 1 equal to 0. So you add 1 to both sides, so x equals 1. So your 0 is 1 comma 0. Now this is a rare occasion where the point actually lies on the asymptote. I don't know why or how it occurs, but it occurs, and it is what it is. All right, now to find the critical points, we're going to graph. So we're going to go to on, new documents, no, add graph. Let's control divide, x minus 1 divided by x squared. Enter, menu, view, grid, line grid. And it looks like we can use the points. This one's a hard one. -1, -2. So negative, and there's my center of the axis. So -1, -2. And you can see that the curve is here. Okay, so that's one critical point, -1, -2. And it looks like our critical point is going to have to be that intercept of 1 comma 0. And you can see from the calculator, it goes slightly above the asymptote, okay? Goes to that point and slightly above, okay? So if you would, go ahead and finish up example 3. All right, now let's take a look at example 4. So we factor. Now x squared we know is 2 parentheses. We know x and x make x squared. Now we need to find all the combinations that make positive 2 combined to be -3. So let's try -1 and -2 becomes positive 2, and this paper's flying around. -1 minus 2 equals -3, so that's our combination. So x minus 1 and x minus 2. Okay. Now here we can factor out an x from both sides, so that's x minus 1. Now you can see here that this divides and becomes 1, so that's where our hole is. So we said x minus 1 equal to 0. So we add 1 to both sides, x equals 1. Now, but it's a point, so we need to plug it in, excluding what's 1, x minus 2 divided by x. So f of 1 equals 1 minus 2 divided by 1, which equals -1. So our whole is 1 comma -1. Okay, now that's an open circle. So and I'm gonna put a little x here for my axis. I know it is. So I go 1, negative 1, and there's an open circle at that point. Okay. Now, for the vertical asymptote, we set the denominator equal to 0, so we have x equals 0. Well, that's done. Oh, wait a second. Almost forgot. I always want to write the vertical asymptote in the 0 section. Vertical asymptote x equals 0. And then x minus 1 equal to 0. Let me make sure I leave space for that. So add 1 to both sides. X equals 1. So we have vertical asymptotes at x equals 0. Oh, but wait, almost forgot. This is gone. So, and you have to be careful with that. Because this is gone, it's not a vertical asymptote. Okay? So we only have a vertical asymptote at x equals 0. Okay? You have to be careful. If this divides and becomes 1, we don't use it. Okay? Now, for the horizontal side asymptote, we divide x squared minus x into x squared minus 3x plus 2. Okay? Then you ask yourself, well, what do you multiply x squared to give you squared? The answer to that is 1. There's no x, so it's a horizontal asymptote at y equals 1. All right, now let's graph to find the critical points. So on, new documents, no, add graph. So we press Control Divide, x squared minus 3x plus 2 divided by x squared minus x. Menu, view, grid, line grid. I should probably finish up the video because the class is about to start. It looks like we can use a point -2, +2. So -2, +2. So our curve is right there. And then it looks like we can use a point, that hole shows us that we can use there. It's not a critical point, but let's just use it for our curve. Okay. And then lastly, find our zeros. Now, the zeros we set the numerator equal to 0, so x minus 1 equal to 0, x minus 2 equal to 0. When you add 1, you get the point 1, 0. And when you add 2, you get the point 2, 0. So we have, there's 1, and, but wait, again, you got to be careful. This divided out, so you can't use this. So you only have a point at 2, 0. You have to be careful in the whole, you don't use that. So you use the x minus 2 equals 0. Okay? So if you would, finish up your examples, and then you're done for the day, and we'll start the assignment on Friday. So with that, have a wonderful Wildcat day.